Ontario Food Protection Association for this opportunity to talk to everyone here. And what we're going to do is I'm going to present the fundamental of cleaning and sanitizing in food processing plants and show some critical overlooked areas in these food processing areas or food processing plants. I would suggest if you have any questions to keep the questions to the end after we finish the presentation. It's a little long presentation because I'm showing a lot of examples of overlooked area in food processing plants and how we do the corrective actions to fix these problems. So before we start, we're going to talk about the cleaning and sanitizing steps and why do we clean and sanitize. We're going to talk about that. So why do we clean and sanitize? First, we have to clean. We all know before we do sanitizing, we clean. So the questions that come to mind is, why is it important to wash away food soils from the equipment into the drains? And the answer for that is because food residues that stay on the processing equipment after production contain microorganisms, especially if you are dealing with raw material that like a chicken and meats and stuff, raw chicken, raw meat, raw materials are considered contaminated and therefore has to be treated as raw, meaning contain microorganisms. So food processing equipment that we process this food with will contain microorganisms in that food residues. And of course, we can't leave them on the surfaces because other than contaminating the surface, it will also protect the microorganisms from the effect of the sanitizer. If we don't remove them from the surface and expose the bacteria to the sanitizer, we will not be able to sanitize the surfaces to a safe level. So what would happen to the bacteria if there is no food left on the processing equipment? So usually we remove all the food, all food residues, all the soils from the equipment. And if any bacteria stayed on the processing equipment or was in the air and ended up being on the processing equipment, it settles on the processing equipment. If the surface of this equipment is clean, the fate of the bacteria is death. It will take a couple to few hours for the bacteria to die because there is no nutrients for it to survive and multiply, right? So when we clean the processing equipment, we usually use detergent, and most likely they're alkaline detergents, right? Do these alkaline detergents kill microorganisms? Even if they were, let's say, chlorinated alkaline cleaners, do we clean to kill microorganisms? The answer is no, because these detergents are formulated to remove the soil and most of the microorganism loosen up from the surface, right? And then when you spray water on the soap, after you finish, you foam the surface or you clean it with the detergent, then you rinse with water, all these food residues and microorganisms, most of them are washed away from the surface of the equipment. So detergents do not kill microorganisms. They wash them away from the surfaces into the drain, but not 100% of them, most of them. And that's why we come back and do the sanitizing step, which we will be talking about that. Again, do detergent wash away all microorganisms from the surfaces? No. And the reason is there are some microorganisms after you clean, right? There are some microorganisms stay on the surface. They are stubborn microorganisms and they start forming biofilm or the polysaccharide matrix they produce when they start making a biofilm. With that polysaccharide matrix, they stick themselves to the surface and protect them from the soap. Because polysaccharide, which is like a gluish material that they produce and protect themselves, coat themselves with it. is not affected by a regular detergent. It takes very specific chemical to penetrate that thin biofilm they use to glue themselves to the surface and to protect themselves. This is another issue. It's like a biofilm, but we don't get to that level when we clean every day. We have a very, very, very thin layer of the polysaccharide where these stubborn microorganisms stick themselves to the surface. And when we come with the sanitizer, we apply the sanitizer, we kill most of these microorganisms. So this is what the second slide says. Why do we sanitize food preparation and processing area after we clean? It's usually to eliminate stubborn microorganisms that stay on the surface, which I talked about. They start making a little biofilm. They're stubborn. They stick to the surface. They are not washed away into the drains. So what is the sanitizer? Before we talk about the sanitizing action, let's define the sanitizer. To sanitize means to reduce the number of microorganisms to a safe level. This is not sterilization, which means we are not killing with the application of the sanitizer on a surface. We're not killing all microorganisms. We are reducing the numbers to a safe level. Usually, a sanitizer reduces the microbial count on the surfaces by 5 log reduction. And if there is no at least 5 log reduction with the sanitizer, the EPA would not approve it as a sanitizer. What does a log mean? So let's say we have 1 million bacteria or CFU on particular surface area of a processing equipment, and we apply a sanitizer. This sanitizer should reduce their number. So each log is 10 to 6 is 6 logs. 1 million is 6 logs of bacteria. Okay, each 0 is 1 log. So if we apply a sanitizer, remember, sanitizer will reduce the number of microorganisms by 5 log reduction. Means we take away 5 zeros from the million, it becomes 10 microorganisms. So this is how the action works. The sanitizer, apply it, reduce the number to 5 log reduction, and that means the bacterial level on the surface is a safe level. Whereas when we process the food on this processing equipment that being sanitized, the equipment will not cause any microbial contamination to the food or that causes any harm to the consumers. So do sanitizers eliminate all microorganisms from the treated surfaces? Of course not. We are not sterilizing. We are just reducing their number to a safe level. Is it appropriate to sanitize a dirty or unclean surfaces? No, it's not, because when we spray a sanitizer on a surface that is soiled, have food residues and grease and fats and proteins, this food residues will protect the bacteria, will sit on the top of the bacteria, and when you apply the sanitizer will not penetrate food residues. Even chlorine will not penetrate it. Chlorine dioxide, PAA, quat, none of these sanitizer is capable of penetrating organic matter to reach the bacteria hiding under it. So therefore, it's very important to remove food residues from the surface before we sanitize. Also, food itself absorbs some of the effectiveness of the sanitizers. So let's say if we have a quat, you use it at 200 ppm. This is just an example, okay? This is not a real number I'm giving you. But if we have a quat that is approved at 200 ppm, you apply it on a dirty surface. It's a lot of food there, like boot sanitizing stations, when boots are very filthy and contaminated and dirty with food and dust, mud and stuff like that. And you apply a sanitizer at 200 ppm on it. Most of the ppms of the sanitizer is going to be diminished, absorbed by food residues. So let's say we'll have 100 ppm. Is 100 ppm enough to kill these microbes? No, it's not. And that's why you need to remove all food residues from a surface before you sanitize it. So you make sure that the bacteria is exposed and the strength of the sanitizer is to the fullest. Okay, so now we know what cleaning and sanitizing mean. Let's talk about the detergents in general. They are classified under 2 or 3 different categories. We have Here in front of us is the pH scale. You know, the pH is between 0 and 14. Anything above 7 is considered alkaline or caustic, depends, right? So it's above 10. If a chemical is above 10, between 10 and 14 or 9 and 14 is considered caustic. But the caustic is an alkaline, but it's a strong alkaline. Okay, so anything above 7 is an alkaline, which we daily, these types of detergents or chemicals are used daily to clean the surfaces, to remove organic matters from the surfaces, including carbohydrates, proteins, fats, cellulose, all kind of things that you have on the processing equipment. This, what we use is alkaline detergent to remove them. And then below 7, a pH below 7 is called acidic. It's an acidic range. And these are the acidic detergents that we use also in food processing plants, but these are not used to clean. These acid detergents are used to descale mineral deposits from the surfaces, mineral deposits like hard water, right? We've got calcium carbonate in the hard water, have magnesium carbonate in the water. Also, if the detergent, the alkaline detergent, dries on the surfaces of the equipment, and we'll talk about that, or how it happens, this acid detergent will leave the alkaline detergent, when they dry on the surface, they leave alkaline residues on the surfaces. And that's why we always have to rinse the foam or the alkaline detergent from the surface before it dries. Because if we leave it, it will leave alkaline, white, chalky kind of film on the surface. And to remove that, we need to use an acid. And that's why we always recommend using an acid cleaner or descaler. That can be called cleaner or descaler, although they are not to clean like from organic matters. We use them once a week, and the alkaline detergent should be used every day of the week. Okay, so acids is for descale, alkaline is to clean the surfaces of the equipment every day. And 7 is a neutral, like water. There are some neutral cleaners that are used on very sensitive metals, like copper or galvanized or those sensitive kind of surfaces, because if you apply a caustic on it, it could harm them. And that's why we use some neutral cleaner. Now, their strength is much less than the alkaline cleaners. And that's why we like to use alkaline cleaner better to do the cleaning instead of us. So now let's talk about the main steps for cleaning and sanitizing in food processing areas, right? We have to move step by step when we clean. The first step, and we're going to talk in details about each one of those, is dry pickup. We dry pick up all debris. The second steps is to pre-rinse, is wet all the equipment, rinse them with warm water, remove as much residues, food residues with water as possible. And then we apply the detergent, whether it's foaming or manual, whatever, even in CIPs, you do the same. And then after we apply detergent, let it sit for a while. We rinse it with warm water. We rinse the soap with water. And before we sanitize, of course, we are going to inspect the equipment to make sure they are clean and there is no food residues on these surfaces. Because remember what we said, we can't sanitize surfaces that contain organic matters on them. So if we find out that the surfaces are still not clean enough, we have to re-clean again. And that's why we do the inspection. So we re-clean and rinse the surfaces until we make sure that the surface is completely clean. And then the last steps comes, which is sanitizing. All right. So why do we do the dry pickup? Dry pickup is to remove the big particles of the food from the surfaces before we rinse the surfaces with water. This step is an essential step to reduce water consumption, because if you have big pieces of meat or chickens or bread or whatever they are processing in your facility, if you follow that with the water hose from where you find it to the drain, each piece by piece, you are going to have a lot of water consumption, and also you will have a drain problem. So we remove all these big chunks of food from the surfaces into the trash can, right? And also when we do the dry pickup, it will reduce the amount of organic matters in the drains, which reduces the BOD or biological oxygen demand in the wastewater. But the biological oxygen demand is the amount of oxygen that is required by the bacteria or aerobic microorganism to decompose these organic matters. So the wastewater will have no oxygen in it, and that's why you need to remove as much possible of the organic matters from the surfaces so they don't go into the drains, into the wastewater, because if you have a high BOD because of these organic matters, your employer will pay a lot of money to the city to clear that sewer water from all these organic matters. Okay, so it's very important step to do dry cleaning. So after we pick up, after we do a dry pickup, we rinse the equipment with warm water, usually 120 to 150. This is a very important step to remove all the gross soils deposited on the surfaces and the greases. Now, if you have blood in your food processing plants or have very high protein residues on the surfaces like egg yolks and eggs and stuff like that, it's better to use cold water, because 120 to 150 sometimes, if you go higher than that, you will cook the protein on the surfaces. The blood has a lot of proteins in it. So if you have blood, use cold water to rinse with. But if you have other stuff like chicken processing plant that have a lot of grease, meat processing plants, or tortillas, or you have a lot of grease, use always warm water, 120, which will melt the fat that is deposited on the equipment, remove as much fat and food residues from the surface with that warm water as possible, but it will not cook the fat and the greases on the surfaces. Again, water above 160 will cook the soil, coagulate the proteins, and precipitates the water hardness. Also, you will have a lot of water hardness problem if you use water hotter than 160 degrees when you clean or when you rinse with hot water. So after we rinse all these greases and food residues from the surface, we apply the detergent. There are different ways to apply detergents. We have the manual cleaning, where you scrub with the green pads. You have a soaking, you have a COP tank, you soak parts in there with detergents, and you have a clean in place, which is the CIP system. Also, you can apply detergent through the CIP system. And then we have a foaming, and then we have high pressure cleaning. The most employed procedures usually are the foaming procedure and the CIP cleaning and soaking. Manual is mainly for difficult to clean areas. You need to scrub them, or for very, very small processing areas like in a supermarket or something. You don't use a lot of manual scrubbing of all the processing equipment in an institution unless it's very, very small. So after we apply the detergent, we apply it as a foam, let's say, on the surface and let it sit for 10 minutes. And remember what I said, do not let the detergent dry on the surface, because even if you rinse it after it dries, you will always have white film of water hardness or calcium and magnesium carbonates on that surface. And that is not good to have in a food processing plant, because bacteria will cling into those mineral deposits, even live in their pores and protect themselves from the sanitizer. So you need to make sure that the processing equipment are shiny and has no mineral scales on them. Okay, so after we foam, we're going to rinse with water between 120 to 150, remove all the detergent from there, and do not let the foam dry on the surfaces. All right, and then after we rinse, we sanitize. We inspect. We inspect the equipment for cleanliness. Final step before sanitizing, to identify any deficiencies in the cleaning process. Make sure everything is clean. Use a flashlight. Look like this guy in the picture there, making sure there is no food residues on inside the tanks or on the surfaces. And if everything is okay, we'll continue with the next step. If we find some food residues on the surface, we need to reapply the soap and scrub and remove all clean the surface and then do the sanitizing, which is the reduction of microbial population to a safe level. Remember those stubborn microorganisms, we are going to spray the sanitizer on them and remove them from the surface. Follow always labeled directions when you apply a sanitizer. Do not use a sanitizer that says apply it at 200 ppm on the label. Do not use it at 150. Do not use it at 100, because that will not kill all the microorganisms. And the ones that are still alive might build resistance to the sanitizer. And this is how one of the ways where microorganisms can build resistance to sanitizers when you apply for a long period of time a sanitizer at less than what's recommended on the label. That creates resistant microorganisms, and you'll start having problems in the plant with microorganisms that are resistant, and you'll have biofilms and problems like that. So always make sure you titrate the chemicals, make sure the sanitizers is applied at the EPA labeled as the EPA approve it on the label. 200 means 200, and that's what you need to be using. Do not ever use a pump-up sprayer to sanitize. Those little ones that I have a picture on the top of there, I always, many times I hear from customers they are using these sprayers. These sprayers do not cover the entire surface with the sanitizer. You need to flood sanitized processing equipment to make sure you hit every inch of the surfaces of the equipment with the sanitizer, okay, to kill them. Make sure to cover the entire surface with the sanitizer. For when you sanitize, do not use hot water. The maximum, if you have hot water, you can use is 110, because hot water will affect the effectiveness of the sanitizer itself, meaning you will have less, some of the sanitizer will gas off, so some of the active ingredients will gas off, so you will not have as an effective sanitizer as you want it to be. So always use ambient temperature or regular water temperature when you want to sanitize. And again, if you have to use hot water, don't use it at hotter than 110 degrees. All right, I can hear you laughing here. Please mute your line if you're laughing. What should we clean? In food processing plants, a lot of people focus on processing equipment and processing areas, the floors. This is not enough. So let's talk about this and read them quickly, because I want to make sure that you guys clean all this. And probably there are more areas to clean. So we clean food processing equipment, food contact surfaces, and non-food contact surfaces. The underside of the equipment, inside the processing equipment, inside their gear boxes. You need to make sure they are clean, okay? Underside the processing equipment, the underside, even the floors under the processing equipment. Electric operation boxes, open those boxes, make sure there's no water sitting inside there and slime, which is a biofilm. Use alcohol to clean the electric boxes. Walls and as high as possible. When you clean them, go as high as you can with the walls. The entire wall should be clean on a regular basis. You have to put it on the SSOPs to clean it from the ceiling to the bottom. The floors included under food processing equipment have to be clean. Fatigue mats, floor drains, chemical dispensing units, the units that you use to dispense the chemicals with, like foamers, sanitizers, all the hoses, the unit itself, you have to clean it, because these workers are touching the hoses and the equipment after they clean the processing equipment, and sometimes they lean on them while they're sanitizing, that will recontaminate this equipment. So these units have to be clean. The ceiling themselves, okay, the overheads, ceiling cooling units should be in critical areas or cooked areas should be cleaned every week, because Listeria loves ceiling cooling units. They're cold and wet, and they survive in there. And if you have Listeria in those cooling units, you'll have it all over the plant. Ventilation system itself, the whole ventilation system, ventilation hoods. If you are cooking and you have hoods for the vapors just to go out, you have to clean those hoods on the inside, even the pipes that takes everything outside the plant. The cleaning tools and brushes. The shipping and receiving ducts have to be cleaned. Okay, I can hear the laughter again. Shipping and receiving ducts, floor scrubbers have to be cleaned as well. The floor scrubbers, the unit themselves, their brushes, their squeegees, the underside of the scrubbers, the tanks that hold the water and the detergent. The coolers and freezers have to be cleaned because even in the cooler and freezer, microorganisms can survive. Some of them can grow like mold and yeast. Others like bacteria will stay alive, but some of them will even multiply on a very slow rate. But it also coolers and freezers have to be cleaned on regular basis. Freezers once or twice a year, coolers once a week. Loading and receiving duct, we said that. I don't know why I mentioned it twice. Trash receptacles and inedible containers and carts, including the wheels. All those have to be cleaned. All right. So now I'm going to show you some real life examples of areas that are usually overlooked. But before that, let's talk about this overlooked area. What do they do? Overlooked areas create microbial niches, right? Microbial niches are the source of microbial contamination in food processing areas. They encourage the formation of biofilm. Microbial niches usually are created when there is an area that is left alone without cleaning. It's difficult to clean. It's maybe hiding. We are not seeing it. This is what the areas are created, the microbial niches. They mainly contain biofilm because the bacteria sitting in there, nobody touches them, nobody removes them, nobody cleans that area. So they stay there, multiply and create biofilms, which is a main source of contamination in food processing plants. Usually formed in areas where they are not cleaned or scrubbed and sanitized like frequently or as needed. And by letting the water stand more than 2 hours in those areas. Like some corners of food processing areas, they are always wet. There's standing water in there. The water stands for 2 and maybe 20 hours, 24 hours sitting there. You cannot let the water stand more than 2 hours in processing areas because biofilm will start forming on the bottom of this, on the floors and the bottom of the water. By not scrubbing difficult to clean areas, you create microbial niches. When equipment are not disassembled as required, a lot of food residue stays between the parts, and these are considered also microbial niches where there is a lot of biofilm formed in this area. That's why you have to break the equipment apart, scrub all the parts, and then put it back together if the equipments are made to be disassembled and cleaned. Also in cracks in the walls and between the walls and the floors. If you have cracks, seal them. Okay, so if you still have some cracks in there, you have to scrub the areas, those cracks, make sure there is no slime inside them so you don't have a biofilm. So lack of cleaning of the hoods and the cooling units, all that will create microbial niches. So let's see what we have, some examples in here of overlooked areas. We've got here a ceiling cooling units in the top picture on the right, right? You see the drip pan has foam in it. What is that? That's not soap, right? And it's not soup. I can call it listeria soup maybe. But this is because the water sitting in the drip pan for a long time. You're not cleaning the drip pans. You're not cleaning the cooling units. You have ice on it. And the water dripping in there and sitting and sitting and sitting, of course, bacteria in this drip pan is gonna form a biofilm and they start breathing and multiplying. When they multiply, they create air and the air creates a foam and a slimy water. And that's what you see in there. So look at the other picture in the bottom, there is slime in those cooling units. And this is a biofilm that contains listeria, okay? So these ceiling units and the ceiling cooling units themselves, all of them, even the drip pans have to be cleaned weekly if possible. Water condensation in the bottom of the drip pan, that's not good. Any water condensation in any food processing plants have to be eliminated. It's either you adjust the cooling system in the plant to pull out humidity out of the area, or if it's not possible to adjust it, update the system, You have to assign somebody every 2 hours to wipe this condensation so it doesn't drip on the food being processed under the plant, under the unit itself. Okay, so what do we see here? Mold growth on the walls, okay, in some processing areas or some wash area where they wash equipment, even storage areas, you've got this mold growing on the wall. This is not good. Mold have billions and billions of spores that floats in the air from one area to another, from one surface to another, and that's how they germinate and make more mold in the plant and contaminate the area. So when you see those, always foam them with chlorinated detergent, scrub the surface and flood sanitize it. Do not let this mold form on the walls this ways. Now we have here a spiral freezer exit or entrance, or it's either way, entrance or exit. The inside of the freezer is cold, outside the freezer is warmer. Because of that, around the belt in the window that the belt enters carrying the food or out of the freezer into the freezer or out of the freezer, you have windows. Because the variance in the temperature between the inside and the outside, water or humidity accumulates on the frame of that window or that exit or entrance. And because that water is sitting there all day and nobody is cleaning that frame of the window daily with the cleaner and sanitizer, you see this darkness in there. This is biofilm. This is mildew or biofilm. And every time, if you have it above the belt, also it will drip because of the water condensation on the frame, on the food that is being on the belt and contaminated. So you have to clean those exits and entrance of the of the spiral freezers. What we see here is a pink yeast or the pink bacteria. Depends on what's going on there, but it's a biofilm. When you let the bacteria grow on the silicone caulking between the boards and the floors, or between the floors and the walls and the pieces of the walls, you have to clean those silicone caulkings all the time because they are prone to have biofilms and slime on them if you don't clean them. And that's a source of contamination. This is a biofilm. So if it was listeria, every time you spray water on the wall, right, the water will carry some of the listeria onto the floors, and then you test the drains and the floors and you have listeria and you don't know why. So you have to scrub these areas. And if the silicone is loose, you need to remove it and put new ones in there, right? So you don't have this problem. This is actually, the top picture is in a washroom. The top picture on the right is in a washroom. They think that it's a washroom. We're not processing food. Why would we clean the walls in there? We don't care about it. This is a big problem. Under that mold growth in there, there is a lot of bacteria growing in there. It's very slimy. And so it contains pathogenic microorganism, which is bad bacteria in there. And then every time you spray water on the wall, water will run down on that biofilm to the floor, contaminate the floor. When people enter the washroom, go back into the processing area, they carry all these bacteria with them. So you cannot leave them on the walls. So these are the electric connections. These are water resistant, yet a lot of workers are afraid to touch them and clean them. When they see them, they stay away from them. Because of that, because they are not cleaned and sanitized, they get greasy and covered with food particles. And because of that, bacteria will grow on them and form biofilm. If you look at the wall behind them, how dark it is, you have a lot of biofilm and bacteria. You cannot have that in food processing plants. Those connections are made waterproof and you have to clean them. And so is the wall behind them. You can't have those in food processing areas. Also, we have floors. The epoxy coating of the floors is bubbling up. Maybe what they put the new coat, the floors were wet. It didn't stick nicely on or firmly to the previous coat. So the floors are bubbling, and every time you step on the bubble, slimy white water comes out of from underneath the bubble, right? And that slimy water is biofilm. And do not be surprised if you find listeria in it, because that's where listeria love to hide under that second coat that's bubbling. So if you have a problem like this, remove all these bubbles as much as you can until you can't pull anymore, and clean the frols, scrub them. Use a Perquat technology to remove biofilm. We'll talk about that in the last slide. That will remove biofilm. You have to scrub it and then put a new coat, but you have to wait for the floors to dry completely so you can put a new coat. I will not bubble up like that. Here is an area where it's close to a chemical. It's a processing area close to the chemical room. A lot of chemicals ran on the floor and ate the concrete. Obviously, it's acidic chemicals. Ate the concrete, made the concrete level of the floors lower than the lip of the metal drain. So the water was standing there all the time. I was called to this plant because they told me I have listeria problem. On the floors, we don't know why. Well, the water is brownish, slimy, and it's a biofilm. That's why the water is standing there 24/7. So these floors have to be fixed where the slope of the floors will maintain a dry floors. All the water will drain into the drain, so we don't have a standing water in there 24/7, and that water became slimy, full of biofilm. So again, do not let the water stand more than 2 hours in a food processing area. So we have a slime and biofilm build up inside the hood exhaust pipe. This is one of the hoods in food processing plants where it pushes the air out that contains a lot of humidity or vapor from the cooking. Look at that hood pipe. This is probably 3/4 of a foot pipe. And they had bacteria on the floors under the hood. They didn't know where it's coming from. Of course, the steam is condensing inside those pipes and dripping down, carrying all this slime or bacteria from the slime, which is listeria. So even the hoods, exhaust hoods, and pipes have to be cleaned all the time. Otherwise, you'll have a lot of problems. You have to scrub them and clean them and put them in the master sanitation schedule to be cleaned on regular basis. So you don't have a problem like that. This is a CIP pipe. Obviously, they're not doing a good job cleaning it. You have a biofilm in there. Always use, when you run a CIP system, make sure that you have the speed, the velocity of the liquid, of the detergents or the water inside the pipes is 5 feet per second minimum. So it will do some agitation, some physical action, and remove the organic matters from the surface. And then when you rinse as well, so you always make sure you're applying the right detergent, right concentration to remove all food residues. Otherwise, you're going to have bacteria and food residues left, bacteria hiding in it, form biofilm like you see. And then you will be, every time you process food in this CIP system, this CIP system, you'll have contaminated food. So always use acid detergents also to remove the scales, so no food residues will stick to the mineral deposits inside the pipes. All right, we have biofilm slime inside a spiral cooler air blower. You see that's where the arrow is? You have a slime there. This is, you see ice. You see ice on the cooling coils, right? Like I said, microorganisms can grow in the coolers and in the freezers. And that's why you need to clean those cooling coils and the blowers all the time. Anything in food processing plants have to be cleaned. If not daily, have to be put on this master sanitation schedule. Because remember, there's food particles in the air, there is dust, there is stuff. And if you don't clean them on a regular basis, they will accumulate. And bacteria will also multiply on the surfaces and form biofilm, which is very dangerous source of contamination in food processing plants. They are wondering in these drains, why do we have listeria in there? I mean, look at the cracks in there. No matter how clean the floors are, these cracks, we have water in there, food particles, food, bacteria all the time. Before you clean anything, before you apply any detergents and do any remediation of or solving the problem of listeria, you have to fix the drains. You can't have cracks like this between the drains and the floors, this will create problems with listeria and with biofilm. Okay, so all this have to be caulked, and then after that you apply the detergents that you need to apply, the sanitizer you need to use to kill the bacteria. Because no matter what you do, if you have those cracks, no matter what you apply and what you use and how much you clean it, you'll always have positive results with pathogens, with microbial testing. This is another example. They were wondering why we have listeria positive test in these drains. Like if you look, these are the two parts of the drains, the pipe, the top part, which is the orifice or the opening of the drain, is connected to the white pipe, which is below the blue line. That's a underground pipe going down. They're connected with silicone, the blue silicone there. And in there is slime. You see that? That slime is what the source of contamination. So no matter how much soap you put in that drain and how much sanitizer, if you have a slime, which is biofilm, which is not removed with the regular detergents and sanitizer, you will always have listeria. So make sure you don't have any cracks or slimy surfaces inside the drains as well. Fatigue mats can be a very dangerous source of contamination, especially if they are old and not cleaned on a regular basis, because they absorb all water, they have big pores. The material will have bigger and bigger pores as the older they get. They become like a sponge. So they will absorb all the food and the food residues and bacteria into them. And every time you step on them, juice comes out of them like a sponge, which can be bacteria and contaminate the floors. So if you have old fatigue mats, please throw them away and get new ones that are not spongy, not very soft, because the softer they are, the bigger the pores they have and the more water they absorb into the material or the fatigue mats. I would rather have none of those fatigue mats in food processing plants. But if you have to, get the ones that are not very soft. Cracks on the walls and between the walls and the floors are dangerous. Do not always seal those cracks. And you see these walls are metal on the top image in the right. These are metal because of the water standing there. They are rusty and they cracked, and the water deposit between the wall and the floor, causing biofilm. The best solution for these type of walls, or any walls in food processing plants, is like the image on the right and the bottom. We call concrete coving. To build the concrete coving that will protect the walls from deterioration, from physical action, from forklifts, from water, so they don't get rusty, they don't get bumpy like the other picture, the third picture on the right. This is because of the water went inside the wall and ruined the wall, and every time they spray water on the walls, the water goes inside the wall carrying food and bacteria, and then eventually from inside the wall, these bacteria will come out to the processing area's floors from cracks in the bottom of the wall and contaminate the floor. So always fix any cracks you have in the walls and between the walls and floors. What we have here is light fixture. They spray water in there, water accumulates in the fixture. They don't clean, they don't remove the cover of the light fixture to clean it. You have biofilm, and the water would drip there, was dripping from that light fixture cover onto the food being processed under it. This had to be put on the master sanitation schedule to be cleaned on a regular basis so you don't have a biofilm problem in the light fixtures like that. Rough weldings, these are not good because food particles will stick to them. Microorganism will stick to those food residues, form biofilm, you'll have a source of contamination. Smoothen out all those weldings when you have equipment like this, okay? Also, look at this. All the parts look very shiny and nice, but why do we have parts in the bottom shelf? This is a drip pan for the water. So all the water dripping from the other shelves accumulating in the bottom drain, and they sit there all day. Water accumulating in food plants, like water accumulating on the floors, will have biofilm in it, contaminate the parts that are sitting on that particular shelf, the bottom shelf, and contaminate the floors. They should not be putting any parts in that lower shelf in there. This is a drip pan, okay? that need to be washed also on a regular basis. All right, this is a very common area or picture in food processing. You have conveyor belts carrying food from from point A to point B in processing plants. Some of these conveyor belts, especially the old ones, have these rollers that carry that drives the belt, right? If you look at that, where the arrow is, the gray cover of the roller is different than the roller itself. So there is a crack between them, which means water can get inside the rollers and food and bacteria. And so when you clean the equipment and you are not cleaning inside the rollers itself, this this food and water stays in there and form biofilm. So when you clean all the equipment, you test the surface, everything is negative. You run the belt, you test the roller and the belt again, and they are positive with listeria, and you don't know why. Well, because the biofilm inside the roller, the bacteria in the biofilm inside the roller got out of the roller because of the centrifugal force. When they rotate the rollers, they force whatever is inside the rollers to go out, including bacteria, and contaminate the belt, contaminate the roller, contaminate the area around it, and that's why they're having listeria on their belt and in their food. So what you need to do is put these rollers on a master sanitation schedule to be taken apart, cleaned on the inside with brushes, and so is the cover put back together. If you have the budget to have a solid rollers without the need to having two parts, like that plastic cover, some of them come like solid roller, no cover to it, so nothing gets inside the roller. This is your best option. All right, they were testing for listeria. They found listeria on the floors. So when I was wearing gloves and inspecting the area, you see that piece of machine sitting on the floor. There's a little legs in there, making the frame a little higher. So I stuck my hand underneath on the under surface of the equipment, and I found this black slime. That black slime on the underside of that equipment. And this is a biofilm that is carrying the listeria. And every time they spray the equipment with water, the water runs on the top of the biofilm down to the floor, carrying listeria and contaminating the floor. Okay, so underside of the processing equipment should be clean. This one here, this is a gearbox. Okay, this is a cover of the gear. You see the gearbox, the bottom picture is the box. It has the gear, and the top two pictures are the cover for it. Because they don't open it when they clean, food accumulated, and look how rotten the food is. It's all biofilm and bacteria in there. And of course, that will cause microbial contamination to that particular piece of equipment that has a belt. Actually, as you see in the back, it's like driving gears for the conveyor belt. So you have to open all the gear boxes, all the electric boxes, to make sure there is no food residues inside them. Ice accumulating on the bottom of the cooling units. That's a no-no. First is hazardous. Second, some of that ice will hazardous to the workers. If pieces of it falls on the worker's head, it will, hurt the workers. And second, if the ice start melting little by little and drip on the food, it will contaminate the food. This is dust and mold growing on the cooling unit's drip pan. Look at that. So at some point, the drip pan had water in them. Then they start getting drier and drier and drier. Mold grew in there. They didn't clean those. You have mold problem in the plant. They don't know where it's coming from. It's from their drip pan. It's mold like caked up on those drip pans. So of course, their spores is going to spread all over the plant and contaminate the wall. So all these drip pans of the ceiling cooling units have to be cleaned. Ice, as per the GMPs, this is wrong. You can't have ice in the freezers like this. Obviously, there was some water leak on the ceiling running on the boxes that have food in them, and that water leak froze in the freezer. That should not happen in food processing plants. You've got liquid food burnt on the surfaces due to the boil out overflow. Well, okay, we cleaned the inside surface, we boiled it out. Why don't we clean the outside? Apply an acid to remove all these burnt on deposits of the food on the external surface of the kettle. Make it shiny. Keep it shiny with an acid cleaner. Every week, apply cleaners on that. And before you apply the acid cleaner, you need to use an alkaline, of course, to remove any greases and fats, and then you apply the acid. This is a COP tank. And another piece of equipment there. They have white scales. White scales encourages the formation of biofilm. Bacteria will cling into these white scales and hide inside them and form biofilm. So use acid to descale them every week. Don't let the calcium accumulate that bad inside and outside the tank. That becomes a source of contamination. And if you have an auditor, a third-party auditors, you would not like this on the food processing equipments. So all it takes is once a week with an acid, foam the equipment with an acid, let it sit for 5 minutes, rinse it off. You'll have equipment shiny all the time. And look at this. This is probably a dishwasher or tray washer. It is because they don't descale it. They're using alkaline with hot water in